Okay, so we have this next question. An ingot copper weighs 89 newtons in air. Okay, so letter A, what is its volume? Second is, the ingot is suspended from a rope and totally immersed in water. What is the tension in the rope? Okay, or the apparent weight of the ingot in water? Now to solve for letter A, the volume. Okay, so we'll use the formula for density. Okay, so we all know that dun sa mga previous videos natin, so for the solution, okay, we know that density is equal to mass divided by the volume. Okay, now in this case, we are given the force or the weight which is in newtons. So pwede natin ito gamitin, okay, para makuha itong volume. Now how do we do that? Okay, kailangan nating malaman dito ano ba yung density ng copper, because by knowing the density of the copper, and if we can get the mass here, okay, sa weight ng ating ingot copper, then we will know what is the volume. So the density of copper, the density ng copper, Cu, is equal to 8,940 kilogram per meter cube. Now, saan yan galing? So you may search on this one for the value of this one. So density ng ingot copper is 8,940. This is a constant, okay? Now, alam na natin yung density ng copper. We have to solve for the mass coming from this weight. So weight of copper is equal to mass times gravity. Now, the weight of copper is 89 newtons. Yung mass, okay, di natin alam. The gravity is 9.8 meter per second squared. So to get the mass, we divide both sides by 9.8 meter per second squared. Dito din, 9.8 meter per second squared. So this will be cancelled. So mass is now equal to 89 divided by 9.8. Makukuha natin as 9.08. Okay? So this is 9.08. Okay? Since this is mass, this will be in kilograms. Okay? Na nakuha na natin yung value ng mass. Okay? So since nakuha na natin yung value ng mass, i-substitute na natin siya dito. Itong lahat ng to, yung copper, density ng copper at mass ng copper sa formula for density. So mangyayari, okay, mangyayari dito is density ng copper, which is 8,940 kilograms per meter cube, is equal to the mass, okay, the mass, 9.08 kilograms divided by the volume. Okay? Now, cross-multiplying sa kabila, so aakyat ito sa ibabaw. Ito namang 1840, lagay natin sa ilalim. Okay? So this will become volume of the copper is equal to 9.08 kilograms divided by 8,940 kilograms per meter cube. Okay? So our final answer here, 9.08 divided by 8,940. So medyo maliit, okay? Yung value, it's, okay, 1.02 times 10 raised to negative 3 meter cube. Okay? So this is the first answer. This is our answer for letter A. Okay? Now for letter B. The ingot is suspended from a rope and totally immersed in water. What is the tension in the rope? Okay? So here, so to illustrate, we have a rope. For example, this is our rope. This is our ingot copper. Okay? And this ingot copper, while it is suspended in a rope, is also immersed in water. So pagpalagay natin, you have this body of water here. Okay? So the question is, what is the tension in the rope? Okay? So if we translate this drawing into a body diagram, okay, i-illustrate lang natin further. Okay. So this ingot copper is actually submersed in, okay, water. Now, if this ingot copper is submerged in water, there are actually forces acting on our ingot copper right now. First is kung putulin natin yan dito, okay, try to break this one. So if this is our ingot copper, okay, there is tension that is actually pulling it upwards, kaya hindi siya mahulog. Okay, so let's call this T, the tension in the rope. Next is the water inside this container is actually exerting a force, okay, an upward force to our ingot copper. And this force is known as the buoyant force. So since it's going up, so let's call this our buoyant force. Okay? Now, another force acting on this body, okay, is the weight of our copper, which is given sa problem na 89 newtons. So, this is weight ng ating ingot copper. Okay, so this is the free body diagram. Okay, now, from this one, okay, we can create our equation. Okay, summation of forces along y is equal to 0, assuming going up is positive. Okay, so since tension is going up, buoyant force is going up, and W is going down, so we get T plus B minus W is equal to 0. Okay, so ito yung ating equation na mabubuo dito. Now, since yung tension yung hinahanap, we have already wala pa tayong buoyant force, but we have already the weight. So, ano ba tong buoyant force? Okay, na sinasabi dito. To solve for the buoyant force, gagamitin natin yung Archimedes principle. Okay, na kunwari, meron kang container. Okay, and you fill this container to the brim. So, puno yung ating container. For example, puno itong ating container ng tubig. If we drop a stone of unknown volume, for example, meron tayong stone dito, hinulog natin dyan sa puno na container, okay, and we don't know the volume of this particular stone, okay, we will know the volume by, okay, determining the volume of water displaced. Kung pila itong niawas na tubig, okay, or kung ano yung tumagas na tubig from our container. So, yun yung volume nitong stone na pinasok natin dito sa container na to. Okay? So, that's basically what this is. So, the formula for the buoyant force here, according to Archimedes principle, is the density of the fluid, in this case water, times the volume of water displaced, okay, times gravity. Or kung i-compare mo ito sa previous video natin, makikita mo that this is actually the formula for the force. Okay? Density times volume times gravity. So check our previous video. So makikita nyo doon itong formula na to. Saan ito na-derive. So here, using this formula, we can calculate for the buoyant force. So buoyant force is actually density ng water, which is 1,000 kilogram, okay, per meter cube. Our volume displaced, okay, is ito, 1.02 times 10 raised to negative 3. Okay? So 1.02 times 10 raised to negative 3 times gravity. Okay, medyo kulang tayo sa space. 9.8 meter per second squared. So calculating, times 1,000 times 9.8. Okay, so we have the total buoyant force is 9.95, okay, newtons. Okay, so this is our total buoyant force. Now, ito yung substitute natin dito. Okay, so if we modify this equation, kasi we are solving for tension, so tension will now be equal to, kung ilipat natin sa kabila, magiging positive. Itong buoyant force, lipat natin sa kabila, magiging negative. Okay, so the weight is 89 newtons minus the buoyant force of 9.95 newtons. So our tension here will now be equal to 89 minus 9.95, or 79.05 newtons. And this is our answer for letter B. Okay, so this is the solution, and if you have questions, again, you may comment down below, and please don't forget to subscribe to our channel. If you have further questions relating to physics, then you may post it on the comment section also. Thank you for watching this video.